So for today, we are still working with domain and range. It's just going to be from word problems, and we looked at word problems a couple days ago. So it's going to be the same thing, except now we will need to determine if it is discrete or continuous, and we will talk about that here once I read through this problem. So the first problem is a plumber charges a $50 fee plus $100 per hour to complete a plumbing job. The total amount spent on a plumbing job can be expressed by the function T of x equals 100x plus 50, where x represents the number of hours spent on the plumbing job. The maximum time he spent in one day or on one job per day is 8 hours. Find a reasonable domain and range for this situation. So this here, the situation, before we talk about discrete or continuous, essentially to summarize everything is a plumber is coming out, he has a set fee, and he charges per the hour that he is there. So we need, and he can spend, a maximum of 8 hours on the job. So we need to find reasonable domain and range. So with that, we have to first ask ourselves, is this discrete or continuous? And the way we figure that out is discrete. If you guys remember a couple days ago, well, I guess a few days ago now, earlier this week, when we did our discrete graphs, they were individual points. And then when we started our continuous graph, they were solid lines. So the solid lines represented any point value at all, up to like a million decimal places. It could be anything. The solid points where they're not lines, nothing connected, represents meaning it can only be this value and no other value. So how I like to think about it is if it is discrete, you can only get that whole amount for it. So for instance, you go to the grocery store. Well, they're not going to let you buy a half an apple, cut the apple in half, and then go pay for just the half apple. You have to buy the whole apple, and then if you only want to eat half, then you can eat half and throw the rest away, give it to a friend, save it for later and hope it doesn't rot, whatever you want to do with the other half. But you can only buy a whole apple. With continuous, you can have different pieces. So, for instance, money is always a good one for continuous, time is always a good one, or speed is good for continuous because, for your instance, for your speed, it's not okay, you can only go 60 miles an hour or 65 miles an hour. I can go, if we really wanted to get down to the nitty gritty, we could go 62.3489 miles per hour, or you could go 64.5 miles an hour, those types of things. So you can do those decimal increments of it. So discrete is you can only purchase the whole item, and continuous, you can only get, you can have different increments of it. So think continuous, again, majority of the time, money, speed, distance, those are the most common scenarios that you'll come across where it'll be a continuous situation. So this one here, it is talking about a plumber and his hourly time on the job. Well, we just talked about that anything usually dealing with hours can be a continuous example. What we're going to first do though, here, we're going to first I'm going to highlight continuous so I don't have to rewrite it all. Let's highlight it yellow so it stands out. So it is continuous. And we're going to fill in the table to help us visualize this. So our domain, I told you guys a little hint on yesterday, is that the domain is generally listed in the table. So in this case, he can work up to 8 hours. He's not going to work anything over that. So he could work 0 hours. He could show up and just work that. He could work 1, 2, 3, 4, 5, 6, 7, or 8 hours, or really anything in between this. We're going to fill in the table to help us get an idea of his starting amount and his ending amount. So to find our t of x, it is the same process. We are going to do t of x equals 100x plus 50. So if I want to do t of 0, well, he can work 100 times 0 and then add 50. 100 times 0 is 0, and 0 plus 50 now is 50. So let's say he doesn't just have to show up to the job and walk out. He can actually work a whole hour. So if he works for 1 hour, he can do 100 times 1 plus 50. So 100 times 1 is 100, plus 50 more is 150. And we're going to do one more just to make sure that we have the idea. T of 2 hours, 100 times 2 plus 50 more. So 100 times 2 is 200, plus 50 is 250. So you can see that it is increasing 100 each time. So this next one is going to be 350, 450, 550, 650, 750, and 850. So now to do our domain and range. So note that we said it is continuous. So that is like what we looked at yesterday where we had to write our domain and range with an inequality. We couldn't use just listing out. So even though we did our table of values, you will not list out every single one of these values like you did earlier this week because it is continuous. It's not saying he can only work 0 hours or 1 hour or only 2 hours or only 3 hours. He could work 2.25 hours, 2.25 hours. He could work 2.9 hours. Any of these increments in between it, he could work. We just simply did the table to help us fill out our domain and range. Now, if you guys remember on our graphs, when we did our domain, we said, okay, what's first? The starting value to the ending value. And we're going to do the same thing here, just from a table. So we have our starting domain is 0, and our ending domain was his maximum amount of time he could work, 8 hours. And again, we know domain is dealing with our x values, so we're going to place x in the middle. So this is saying he can work anywhere from 0 to 8 hours, or that our domain is any number greater than or equal to 0, less than or equal to 8. Anywhere in that range, any decimal form of it as well. Our range is for our y value. So we're going to do the same thing. Our smallest y value to our biggest y value. Well, our smallest is 50, and our largest is 850. And we know we're working with y, so we put y in the middle. So this one, again, it was continuous because it's saying he can work any set of hours or any fraction or decimal set of the hour. It doesn't have to be a whole hour that he's on the job. And so that made it continuous, which is how we wrote our domain and range here. Now let's look at this example, our second one. Johanna, I think I spelled that wrong. Johanna, let's do that, has $250 in her account and withdraws $50 each month. The function v of x equals 250 minus 50x represents the total amount in her account after x months of withdrawal. State a reasonable domain and range for this situation. So here she has her starting amount, $250, and she is taking out a set amount, $50, and that is on a determined day each month. So she's doing only $50 once a month. So it's not saying she's taking out a random amount of money any time of the day she pleases. It is just this one amount once a month. So since it is just a set value, it's only done one time for 1 month, it is discrete. It's not talking about she's withdrawing money in her account. Generally, it is giving us the specific amount for each specific amount of time. So it is discrete. Now, her X amount of months. X is the months, so we are going to fill in our domain first. Now, we always are going to start with 0 months because at 0 months, she has money in the account. She has 1 month, 2, 3, 4, 5. And we'll see what she has once we get down to here. So showing our work here, we have our equation v of x equals 250 minus 50x. So v of 0 equals 250 minus 50 times 0. Oops, not. So 50 times 0 is 0. So we're left with basically just 250. Like it told us at the beginning, she has 250. So we could also use this and just know she's taking out $50, so this should decrease by $50, but let's prove it mathematically. So v of 1 equals 250 minus 50 times 1. Well, 50 times 1 is just 50, and 250 minus 50 is 200. So we are correct. It is decreasing by $50 each month. So 200 minus 50 is 150, then 100, then 50, and then 0. And we could go a 6 month, but now she's going to get into that negative amount. And I don't know if you guys know, but if you are physically going to the bank and saying, I want to withdraw money and take money out of my account, even though you don't have it, they're not going to do that for you. They will not let you pull money out of your account if it is not currently in your account balance. So that's what there's reasonable domain and range comes in, because it's reasonable to assume that after 5 months she is going to have no money left, so she will not be able to continue making these withdrawals every month. It has a hard stopping point here. It cannot go on any further. So our domain, since it is discrete, is what we did early in the week. We listed out 0, 1, 2, 3, 4, and 5. Those are brackets. Our range, 250, 200, 150, 100, 50, and 0. Again, we do not do it as continuous because she is only pulling out $50 every month, and it doesn't give any notion that she's pulling out more money than this $50 or more frequently or at an unknown amount of time. So with that, it is discrete.